Okay, good evening. This is Professor David J. De Los Reyes. Okay, it's August 25, 2023. In the time is 11:11 p.m. My subject matter for tonight will be college algebra, and this will now be lesson number 42. And the title of the topic is about logarithms. Logarithms. So logarithms, it could be the natural logarithm or the common logarithm or just simply a logarithm with the base of a. Okay, let's proceed. Subject matter for tonight will be college algebra lesson number 42, and this involves logarithms. In the study of engineering, there are two types of logarithms. It is the so-called natural logarithm. If the base of the natural logarithm is 10, we call it the natural logarithm. And if the base is equal to e, and that value e is 2.718281828, okay, we call that the natural logarithm. Natural logarithm is especially used in the so-called study of electrical engineering and the so-called study of subcalculations. Okay, subcalculations of cables. It is just like the San Francisco Bridge. Okay, the graph of the San Francisco Bridge is something like a parabola, but it is nearer to the so-called hyperbola, right? And the graph of the parabola and hyperbola, there is an e over there, and that e is actually this 2.7182828. But just discussing mathematics, the ordinary mathematician just use the common log, but for the natural log, those are especially designed or used by the so-called electrical engineer. Okay, let's proceed. To study logarithm, we should know the properties of logarithms. And since there are two types of logarithms, it's the common logarithm. If the base of the logarithm is 10, we call it the common logarithm. And if the base is e, which has a value 2.718281828, okay, just display one here, and there's a function here e to the x, but it is on the second function, so we will place second function e to the x, and the value is 2.718281828. Okay, that's the base of the so-called natural logarithm. Okay, let's try to bring out the properties. I will try to read it. The logarithm of 1 with the base of 10, and this should be equal to the logarithm of 1 without any base. Under common logarithm, we usually don't place the base 10. Okay? So actually, under the so-called common logarithm, it should all be like this. Okay? We then place the base. It is understood to be common logarithm. But since we are studying just the concept, I would like to say that this without base 10 actually emanates from this. Okay, I will continue. The logarithm of 1 with the base of 10, and this should be equal to the logarithm of 1 without any base. It is understood to be common logarithm, and they should be equal to 0. Okay? How do we know that the common log of 1 with the base of 10 is equal to 0? From the definition of a logarithm, it should be the power to which the base of the logarithm must be raised to equal that number. Because if we will take the base of the logarithm, okay, and we raise that to the value 0, what will come out should be equal to 1. It is this. Okay? I got this because 10 to the 0 is equal to 1. Now, that's the definition of logarithm. For this to be correct, 10 to the 0 should be equal to 1. Because the logarithm of any number is the power to which the base must be raised to equal that number. The number we are looking for the logarithm is 1, right? So 10 to the 0 should be equal to 1. Okay, and if you want to verify this one, then y to the x 0 power is 1. Any number raised to 0 power is actually 1. So this is 1. Okay. Number 2, the logarithm of 10 with the base of 10. The other way to write this one without the base 10 is the logarithm of 10 without any base. It is understood to be common logarithm, and this should be equal to 1. How is that so? Again, just bring back the definition of a logarithm. It is the power to which the base of the logarithm must be raised to equal the number. If we will try to take the base, raise that to the first power, and what should come out is the number we are looking for the logarithm. Okay, because 10 to the first power is just 10. Okay, you got it? And if you don't want to believe in this one, okay, just display 10. Okay, raised to y to the x, the power is 1. What will come out should be 10. But we could do this one by just using these properties here. I told you the logarithm of 10 with the base of 10 should be equal to 1 because 10 to the 1 is equal to 10. Okay? The last part, the logarithm of 10 to the x with the base of 10. The other way to write this one will be the logarithm without any base. It is understood to be common logarithm of 10 to the x is just equal to x. How is that so? 10 to the x is just equal to 10 to the x. Okay? It seems we are taking the logarithm of an antilog. Okay, so what will come out will just be simply 10 to the x is equal to 10 to the x. Okay? Under the natural logarithm, we will just repeat this one. Okay? What do you call this? The proper way to write the logarithm is something like this. The logarithm of, we will repeat this one. The logarithm of 1 with the base a, because under natural logarithm the base is e, right? Equal to the simplified equivalent of natural logarithm. For us to write expeditiously, it should be ln. But don't read that one as ln. It should be read natural logarithm. So without the e here, it is understood to be natural logarithm. Okay? From now on, if you see an ln, that's understood to be a natural logarithm in which the base is e. So I will try to repeat it. The logarithm of 1 with the base of e should be equal to ln, okay, of 1, meaning the natural log of 1. We didn't write the e here, it is understood to be natural log, right? And this should be equal to 0. It's the same. Why is that so? Again, try to bring out the definition of logarithm. It is the power to which the base must be raised to equal that number. Because if we will try to take the base, okay, and we get the 0 here, what will come out should be equal to 1. It should be equal to this. Because e to the 0 power is equal to 1. Okay? The reference is always the base. Okay? Next one. The logarithm of e with the base e. The other way how to write this one is without the base e. It will just be simply ln. It is understood that the base is e and that is natural log. So this one here is same as this one, okay? But the preferred way and how to write it so we could write expeditiously, it will just be simply ln, meaning natural log of e. And this should be equal to 1. How is that so? The base is e, right? And this one here is 1. Okay? Because e to the 1 is just e. Okay, you got it? How about the last one? The logarithm of e to the x with the base e. The other way to write this one will be the natural logarithm of e to the x, and this should be equal to e to the x. It will be e to the x is equal to e to the x. If from the common logarithm 10 to the x is equal to 10 to the x, for the natural logarithm e to the x should be equal to e to the x. Okay, those are the properties. Those are the properties in which we should memorize. Okay, for us to learn the study of logarithms under algebra. Okay, next one. There are laws of logarithms, okay? We'll try to bring out the laws of logarithms because laws of logarithms always come out from the short videos. All the discussions for other bloggers on short videos under logarithms, okay, involves this concepts here. So if we try to bring out the laws of logarithms, number one, if the base is 10, of course it is a common logarithm, right? I will not place anymore the base 10. It is understood to be common log. The common logarithm of the product UB, okay, if we try to expand this one, it will be the logarithm of u plus the logarithm of b. If the operation here is multiplication, the right hand side should be addition. Okay? Next one. The common logarithm of the ratio u over b equal to the logarithm of u minus the logarithm of b. If the operation here is division, right? The operation here should be subtraction. Okay? Last one. The common logarithm of u raised to the n power. If we try to simplify this one, this could be written as the power n we could bring it down. Okay? If we try to simplify this one, the common logarithm of u to the n can be written as n, the logarithm of u. Okay? This one, we could bring it down. Okay? So those are the three laws of logarithms for a common logarithm. And of course, under the so-called natural logarithm, in which the base is a, it's the same. The only difference is the writing. ln is understood to be natural logarithm, meaning the natural logarithm of the product should be the natural logarithm of the sum. It's the same. This is multiplication. The operation here should be addition. Okay? The natural logarithm of the quotient will be the natural logarithm of the numerator minus the natural logarithm of the denominator. So if this is division, this should be subtraction. Okay? The same. The natural logarithm of u to the n is equal to, it's the same as this one except that the logarithm is different. It should be n, the natural logarithm of u. Okay? So with these three knowledge here, if you try to watch the short videos, okay, you can use this concept here to understand what they were saying. Okay? That's why I am discussing concepts. So when you watch the short videos, you will understand it. Because without understanding the concept, you cannot understand the video on the short videos. It's easy to just view, but to understand it is will be a different thing, you know. Okay, let's try to bring out the proper way on how to write Antilog. Okay, because many people don't know how to write Antilog. Okay, for Antilog is the opposite of logarithm, right? The proper way to write Antilog under common logarithm, if the base is 10, okay, this is the proper way how to write an Antilog. It should be 10 raised to the natural logarithm of x, okay? If we try to simplify this one, it will just be simply equal to x. And the other way around, okay, the reverse of this, the logarithm of an antilog, okay, will just be simply also equal to x. Okay? This is antilog, this is the reverse one of the antilog. It's just like in the integral. The integral of the differential of any function, okay, will just be simply the given function, because if the integral goes near the integral sign, they will cancel out. Or the reverse of it, the differential of the integral of any given function is just the given function, because the differential of the integral, if they go near each other, they try to cancel out. It's just like this one here. The antilog of the logarithm of x will just be simply x, and the logarithm of the antilog will just be simply x. Okay? Under natural logarithm, it's the same. Am I still on the camera? The proper way to write antilog in under natural logarithm is you take the base, you raise that to the natural logarithm of x. If you try to simplify this one, it should be x. And the other way around, if you take the natural logarithm of e to the x, what will come out will still be x. So this is read natural log of e to the x. This one, it's the natural antilog of natural logarithm of x. It is just the reverse operation. This one is the reverse operation of this one. So if you know this one, you should know this one also. Okay? Okay, let's try to bring out an example to visualize the importance of the concepts or the so-called laws of logarithms. I will just give you one example for tonight. Find the product of 25 times 28 using common logarithm, right, and natural logarithm. To bring out the solution of this, we will let x equal to the product 25 times 28. So presenting solution number 1, okay, if x is equal to the product 25 times 28, okay, and by using common logarithm, take the logarithm of both sides. The common logarithm of x will be the logarithm of x. It is understood to be the base is 10, should be equal to the logarithm of the product. Okay, and this product here, it seems under the form the product UB. Right? It is under this. Okay? So the logarithm of a product, we must have to use this laws of logarithm. It should be the logarithm of a sum. If the logarithm of a product, if we try to expand, it should be the logarithm of a sum. It should be the logarithm of the first one plus the logarithm of the second one. So simplifying this one, logarithm of x now will be equal to, if we try to expand this one, product, right? So this should be the logarithm of 25, the first one, common, because I didn't place the base. If there is no base here, it is just simply LOG, it is understood to be natural logarithm, plus the common logarithm of 28. The common logarithm of 25, it's an easy thing, just play 25 here. Okay, common log, the LOG over here, first function. So 1.397940. And 28, you just display 28. Okay, first function, LOG, logarithm. 1.447158. Okay. Take the sum. What will come out is 2.845098. That is logarithm of x. So to compute for x without the log, okay, the enemy of a logarithm is the antilog, right? The antilog of a logarithm of a function is just the given function. So to eliminate this log here, we must have to take the antilog of both sides. And to take the antilog of both sides, what's the base here? It's 10, right? So you will get the base. You raise the value on the left, which is log of x, and this should be equal to 10 raised to 2.845098. What you will do on the left, do it on the right. Okay? For common logarithm, the antilog is like this. It's 10 raised to that function. Okay? Equal to 10 raised to the given right hand side. And the 10 raised to the log of x, what's the simplification of that? It is just simply x. Right? It is. Right? And that is read the antilog of the logarithm of x. 10 raised to the logarithm of x is just simply x. And that is read as antilog. Right? Antilog. Okay? So I will repeat it. 10 raised to the logarithm of x, it is read the antilog of logarithm of x should be equal to 10 raised to 2.845098. Right? So the left hand side is x now, the one we are looking for. And the value of the right hand side, just display 10 here. Okay? Y to the x, the power is 2.845098. Okay? Equals. The value is 699.99355. Okay? Or that is approximately 700. This is 700. Because if we try to check it, 25 times 28 is equal to 700. So this is correct. And the solution by using logarithm is this one. And what concept did we use? It's the laws of logarithm, law number 1. That is the logarithm of a product. Okay? That's the importance of the concepts of the laws of logarithm. We could take the product 25 by 28 immediately. But if we try to bring out the solution by using the concept of logarithm, we must have to use logarithm law number 1, the logarithm of a product. Okay, next solution. It's the same. For the natural logarithm, okay, we are given this. So take the natural logarithm of both sides. The natural logarithm of x will be the natural logarithm of x. This is read ln, not ln. It should be natural logarithm. Natural logarithm of x equal to the natural logarithm of the product 25 times 28. Right? Expanding, the natural logarithm of a product is the natural logarithm of a sum. So it should be the natural logarithm of 25 plus the natural logarithm of 28. The natural logarithm of 25, it's easy. You just display 25 here. Okay, ln, where is ln? First function, ln. 3.218875. And for 28 ln, the value is 3.322045 or 04. Take the summation of this. The right hand side will be 6.55079. And that is natural logarithm of x. And to compute for x, we must have to eliminate this natural logarithm here. And the enemy of a natural logarithm is the antilog of natural logarithm. What's the base for natural logarithm? It is e, right? It is e. It is e. So to take the natural antilog of both sides, you take that base, you raise the left hand side to that base, so it will be a natural logarithm of x. Okay? If we try to read this one, it's the natural antilog. Okay? Natural antilog. Why natural? Because the base is e. The natural antilog of the natural logarithm of x is just x. Okay? Where did I get this one? This is. Right? And this should be equal to. The right hand side is just a pure number, right? How would you display e over here? just display 1 over here, right? Oh, sorry for that one. Just display 6.551079, okay? And e to the x here is on the second function, okay? So second function, e to the x. The value is 699.9990655, or that is approximately 700. So the value of the right hand side, that is e raised to this, is 700. So by using the common natural logarithm and the natural logarithm with these steps here, what comes out for the solution is actually x equal to 700 and x is equal to 700. And what concept we use? We use the laws of logarithms, and we use the concepts on how to take the Antilog. Okay, that's it, guys. That's the natural laws of logarithms using the common logarithm and the so-called natural logarithm. So for those of you who are taking college algebra, this is for you guys. If you want to subscribe to my channel is at youtube.com/@ProfDavidJ. If you want to share it, please click share. Try to watch my long video format discussion on college algebra. If you learn the concept, there will be no problem understanding the short videos, okay, that involves problems under logarithms. Okay, good evening from Los Angeles, Professor David J.